Hello and welcome back to the History and Philosophy of Science. This is the lecture for week 2, lecture review, kind of a little review of week 1 is what I want to do, a little intro to week 2. And so let's start by talking about your projects or your 2 assignments for week 1. First of all, what I was hoping that you would get with your graphs, and I have seen this, I think, in some of the data and discussions we've had a little bit answering your questions. I was looking for something like this. Now, I don't know how well you can see this. I can't share my screen here, but what this is basically an exponential growth curve. So we're starting over here. My graph starts at 10,000 BC, and I'm working my way through time. And then I get to kind of the knee of the curve right here, somewhere in the 1600s, and then all of a sudden it just starts to shoot up exponentially. Now on my graph, I have put the cumulative, the total number of discoveries. It's cumulative through time on here, so that I go up as high as looks like I get close to 1,200. At my most recent date. So let me just put this up here. Maybe you can see that a little bit better. That's what we're looking for, the exponential curve. And this is the type of growth that I would call an explosion right here. So something happened, say between 15 and 1600, that caused this to really take off and skyrocket. One of the things that we should note, though, is that on sciencetimeline.net, which is the site that I use and which some of you might be using, they don't always distinguish between inventions and discoveries. So we're really trying to focus on scientific discoveries here, although whether there's a real difference is something we're going to talk about in coming weeks. But before we do that, let me just give you a couple things to think about as we go into the next couple weeks. Things I want you to think about in terms of this curve. What happened that caused this kind of explosion in scientific discoveries? What was it? Was it a philosophical change, kind of a worldview change? What was it that really happened that made all of a sudden all these discoveries started to be made? And of course, for the most part, they were, or the majority of them were being made in Europe and by Europeans. And that's something we're going to talk about in a future week as well. So think about that as we move on here. Think about the relationship with time of the development of science, and then we're going to start to think about how it relates to society as a whole and what was going on in society and what factors might explain the growth of science, the rapid growth of science that we saw in that curve. Okay, the next thing I want you to think about is, as I mentioned, think about the idea of inventions versus scientific discoveries, which is kind of similar to the idea of engineering versus science. What are the differences? Is engineering just applied science, or are they totally different? When we talk about something like the discovery of the wheel, for example, which one of you mentioned, is that science? If somebody's building a wheel, inventing a wheel, is that science? And how do we define science, which is actually where we're going in a couple weeks with this class. But before we get to those questions, in week number 2, we're going to be looking a little bit more at the nature of, or the way that science grows and progresses. Okay, so we've already got kind of an overview. We see that there's, over time, there's an exponential growth in science that we've seen historically. Whether that will continue in the future or not is the subject for the last week of this course, week 6, whether that exponential growth will continue and what that might mean. Okay, we're gonna look at that question. But in week 2, we're going to be focusing on a couple of things. One is the discovery of oxygen is going to be kind of our case study, because it's just a very interesting period in history. We know a lot about it, and it turns out there's this nice play that was created. And what you're going to see online here is I've got the 2 acts of this play put up there so that you can watch it. And kind of an interesting take on this. It's the basic idea of the play is that there's a Nobel Prize committee that wants to kind of retroactively issue a Nobel Prize to the discoverer of oxygen, and then they're trying to decide among the 3 potential candidates. And I'm gonna leave the rest for you to look at. But and then you've got some questions to answer about that for one of the assignments. And then the second part of week 2 is some readings from this book, which I mentioned in the first video. This is Thomas Kuhn, The Structure of Scientific Revolutions. And I picked out 3 chapters of this. And it's a little difficult picking chapters because the book is really definitely best read as a whole book. Okay, but because of that, because we're kind of picking and choosing chapters, it might make it a little bit more difficult for you to grasp what he's saying. So what I think I'll do is give you kind of my take and my overview of his views, so that you're kind of oriented when you go into the chapters to read them. By the way, the PDF of that book is on the website, so you can take a look at that. You can read it in PDF if you didn't happen to get a used copy of it. All right, the basic idea of Kuhn is the idea of the paradigm shift. Now, what is a paradigm? Well, a paradigm is the way that you view the world, or the way that you view whatever it is you're looking at. Think about the Ptolemaic system of the or the Aristotelian system of the universe, where you had the Earth at the center, and then you had everything else going out from there, like the atmosphere, and then the celestial realm. The celestial sphere was on the very outside. Okay, and it all had to do, it was all built into Aristotle's philosophy. And that was one way to look at the universe, and the way we look at it now after the Copernican revolution is very different, with the universe and the Earth and other planets going around the sun. So that's just one example of a paradigm. There's lots of other you could have paradigms in economics and politics, paradigms in your own life. In a way, religious conversions are a type of paradigm shift. Okay, so that's kind of what we're looking at here. And what Kuhn does is he applies that concept to scientific revolutions. Now, when he says revolutions, he's talking about the major changes in science, the major new theories that have taken place. And here's what he says that's been controversial. He says that it's not incremental growth, that science doesn't grow incrementally and kind of constantly accumulating more and more and more knowledge. But what's really happening, in other words, kind of getting closer and closer and closer to the truth over time, that's not what Kuhn believes. Because he looks at science, usually when there's a revolutionary scientific theory, like say Einstein's theory of relativity, or let's just take the oxygen theory of combustion from Lavoisier. Those theories, or maybe Newton's gravitational theory, or Copernican astronomy versus Ptolemaic astronomy, those new theories don't really build on the old theories. They totally get rid of them. They totally replace them. In other words, the phlogiston theory, or phlogiston, as they say, as they pronounce it in the play, the phlogiston theory is not very helpful today. It is not used at all. Okay. Now, there's a little difference between that and when we get to Einstein and his theory of relativity versus classical view. We still use Newtonian mechanics, even though they're technically not correct. It turns out they're good enough for most things. But then again, the Ptolemaic system of astronomy, in which everything was going around the Earth, that could be used to work very well, actually. They had all these little fudge factors that they worked in there, and I think you'll read something about that in Kuhn's book. They had all these adjustments that they made to that system so that it actually worked pretty darn well. Okay? And so did the phlogiston theory of combustion. I'm not going to give you any details on that because you're going to get those in the play in the book. Now here's what happens then. Somebody is viewing the world in a certain way, like say the phlogiston theory or the Ptolemaic system. When they look up at the stars at night, they see everything as going around the Earth. When they see the sun rise in the morning, they see the sun is going around the Earth. How do you break out of that into a new worldview? Well, that's where that's something else that Kuhn talks about. Basically, he says what happens is there'll be anomalous observations. So there'll be things that people see, that scientists see, that don't fit with the current theory very well. But it's not as simple as anomaly and then change your theory, okay? Because here's the thing. Whenever you see anomalous behavior, whenever you see something that doesn't fit your current way of thinking about things, all you have to do is just tweak your theory a little bit. And that's what they did. That's what the Ptolemaic astronomers did. That's what the phlogiston theorists did. They saw something that didn't fit their theory. They just put a little fudge factor in there, or they tweak it. And you'll read a little bit more about that. Like phlogiston theory predicted that when things burn, they would be expected to lose mass. Well, it turns out when metals burn, they gain mass. So what did they do? Well, they invented the concept of negative mass, that things can have negative mass. All right, so if you lose something that has negative mass, then the mass can actually go up. Okay, sounds weird to us, but it's just ways of them saving their theory. Okay, so how do you get beyond? How do you ever break out of it? That's kind of the question. That's one of the questions that Kuhn is dealing with. Usually what happens is some fresh new mind, often a younger person or someone from outside of the field, comes in and is able to look at things in a totally different way. Their mind is not locked into the old way of thinking. And that's when a revolution takes place. And you're going to read about the case of Lavoisier and his really the chemical revolution, what we might call the chemical revolution, really the invention of a modern chemistry was occurring with him. All right. I don't think that I gave you the chapter that has page 62, but make sure you read page 62 and 63, or you might want to. They talk about this card experiment that they did, where they had a deck of cards, and it was a psychological experiment. They would flip the cards up, and people would have to report what the card was. Only it was a funny deck. They had things in the deck like a black 9 of hearts or a red 3 of clubs. Okay? Here's the funny thing. They'd flip through the deck and people wouldn't notice the difference. They would report, if they saw a black 9 of hearts, they would either report like a 9 of spades, or they would report something like that, like a 9 of hearts. It was like their mind was just ignoring the, let me get it here since I'm messing it up. So it says here, even on the shortest exposures, many subjects identified most of the cards. And after a small increase, all the subjects identified them all. For the normal cards, these identifications were usually correct, but the anomalous cards were almost always identified without apparent hesitation or puzzlement as normal. The black 4 of hearts might, for example, be identified as the 4 of either spades or hearts. Without any awareness of trouble, it was immediately fitted to one of the conceptual categories prepared by prior experience. One would not even like to say that the subjects had seen something different from what they identified. With a further increase of exposure to the anomalous cards, subjects did begin to hesitate and to display awareness of anomaly. Exposed, for example, to the red 6 of spades, some would say, that's the 6 of spades, but there's something wrong with it. The black has a red border. Further increase of exposure resulted in still more hesitation and confusion until finally, and sometimes quite suddenly, most subjects would produce the correct identification without hesitation. Moreover, after doing this with 2 or 3 of the anomalous cards, they would have little further difficulty with the others. So basically, they had to be kind of snapped out of or broken out of the old way of thinking about a deck of cards. All right, and that's what we're looking at even in science, according to Kuhn. So have fun with the tape, the video, and the readings, and you're going to write a response to both of those. And this time, instead of putting them in a forum, you're just going to submit them to me as short essays. I don't even think I went with the 5-paragraph form here, like 3 paragraphs or so. But make sure you look at the rubrics for the details. And as always, if you have any questions, feel free to email me at greenwilliamp@gmail.com or wgreen@eosmith.org. All right, and continue to enjoy your summer.